Example 1 here on normal approximations to the binomial distribution is taking a look at when n is large. So we've been given our binomial distribution here, and we're asked to find the probability that x is less than or equal to 130. Well, as n is equal to 250 here, so n is the 250, which is large, and p is 0.55, so p is 0.55 here, which is close to the 0.5 that we require. In that case, we can use the approximation. So we write our approximation here as y. It's a normal distribution with 250 n times our probability p, so 250 times 0.55, and our second parameter here is 250, that's n, times by p, which is 0.55, so if we just quickly with that, sorry, so 0.55 here, so 250 times 0.55, and then we times that by 1 minus p, so that's going to be 0.45 there, okay. So here now, that gives us our normal distribution here, which we can write, if we simplify this, as y is a normal distribution with mean 137.5 and variance 61.875 there. Okay, so we're looking for the probability that x is less than or equal to 130 here. Okay, now we need to apply a continuity correction here. We've approximated, so in that case we need a continuity correction. So that would be the probability. Now, as this is less than or equal to 130, we need to include the 130, so we write this as y is less than 130.5 there, which makes sure that we include the 130. So that's our continuity correction there, and at this stage now, we just simply need to use our calculator to work this out. But what we find here, for the probability that x is less than or equal to 130, this is equal to 0.1702 there. Okay, so that gives us the solution to example 1 there. Example 2 here on normal approximations to the binomial distribution is taking a look at when np and n times 1 minus p are greater than 5. So here we've been given our binomial distribution with parameters n equals 20 and p equals 0.7, and we're asked to find the probability that x is less than 15. So here now, what we need to do is check both parts here. So we need to check np, so that's going to be n times p, which gives us 20 times 0.7, which gives us 14, and 14 is greater than 5. Okay, so that one there is satisfied, so np is satisfied. We just need to check now n times 1 minus p, and that would be 20, so n times 1 minus p is equal to 20 times 1 minus p, so that's going to be 1 minus 0.7, giving us 0.3 there. And that's equal to 6, which is also greater than 5. So therefore, we can use the approximation. So we write our distribution here now as y is a normal distribution with mean 20 times 0.7, and our variance here is going to be 20 times 0.7 times 1 minus p, so that's 1 minus 0.7, so we times it by 0.3 there. Okay, now we simplify this distribution here so we can see what it is clearly. That gives us 14 and 4.2 there. Okay, so because we've approximated to a normal distribution here, we need to also apply our continuity correction. So we're looking for the probability that x is less than 15. So in that case, our approximation here, or our continuity correction even, will be the probability that y is less than 14.5 here. Okay, you can also double check this with your table for the continuity corrections. So in that case, just evaluating this now with our distribution here, we find that the probability of x being less than 15 is equal to 0.5964 there. Okay, so that gives us the solution to example 2 there.